Hi, I'm Hashini Senaratne, and I'm excited to present TronicBoards, an accessible electronics toolkit designed for people with intellectual disabilities. This is a work conducted at Monash University, Australia, with Swamy, Ananthanarayan, and Kirsten, Ellis. TronicBoards Toolkit has 14 custom-made printed circuit boards that can be categorized as power boards, action boards, and sensor boards. Motivated by prior work from the literature and reflections from our preliminary workshops, we have included several accessibility features into this toolkit design, so people with intellectual disabilities can also experience the benefits of using computational toolkits, such as improving their autonomy, STEM knowledge, and mental health. To cater for their diverse interests and abilities, this kit provides various board options. For example, battery or USB power boards can be used to activate boards with multimodal feedbacks of light, sound, and motion with or without controls, and sensor boards can be used to make circuits responsive to button presses, magnets, tilting, touching, light, or temperature. To support the understanding of board connection order, we implemented the traffic light analogy in board design. In addition, different corner shapes were designed to support board category identification. Boards have concave and convex edges and plus and minus signs to support polarity identification. At the rear side of each board, we also included symbols in high contrast to support the affordance of board functionality and circuit symbols to provide an opportunity for learning. To support motor issues associated with intellectual disabilities, the connector pads were designed to be larger, and the size of boards was selected to be easily graspable. We use large push buttons and knobs and slide switches with 3D printed caps to support easy control of board functionality. These boards can be connected through conductive tape, conductive thread, banana plugs, and crocodile clips to accommodate diverse abilities and to facilitate creations with diverse form factors. This kit also has a stand that can assist stabilization of boards when making connections. To assess this toolkit, we conducted one-on-one evaluation sessions with 10 participants who were experiencing an intellectual disability. Our participants represented low to high support needs for their daily activities, and they aged between 19 to 69 years. We conducted these studies at 3 disability support sites, often in the presence of a support worker. The studies typically lasted from 20 minutes to 1 hour and were audio and video recorded. We use guided exploration approach to conduct these studies. During the study, the participants were invited to guess and observe the boards and build circuits using preferred boards and connectors. Exceeding our expectations, each participant could make their own circuits, and the majority of participants made 5 to 6 circuits depending on varying levels of assistance. For example, some only needed indirect or direct verbal assistance or gestural prompts such as pointing to a switch to use. Some required side-by-side or hand-over-hand demonstration, and some needed stabilization support like holding boards when making connections, which could eventually be solved using the 3D printed stand. Our participants celebrated small wins with big smiles, applauding, thumbs up like gestures, saying it works, and soliciting appreciation. They also demonstrated their improved confidence by showcasing their circuits or explaining what they learned to their support workers. 2 participants could also produce personally meaningful digital artifacts collaboratively with us. One of them integrated a circuit to her personal mirror to light it up and decorated it using glitter glue. The other participant created a non-standard circuit consisting of a battery and a music board arranged in a back-to-back manner to help her practice sliding due to her motor control issues. Almost all participants could easily grab modules and use controls such as push buttons and touch sensors without an issue. Usage of slide-in switches and knobs, on the other hand, required repeated guidance and progressive learning for many participants. Participants also easily recognize many boards through visual symbols or their tactile properties, but comprehending some boards such as tilt switch and controls like light mixing require same-then in action. Traffic light colors used in boards supported differentiating boards, but their semantic meaning that meant to assist the board ordering was not often comprehended until we explicitly mentioned it. Also, we identified that shapes of edges sometimes made participants arrange boards in a horizontal direction, resulting in wrong corrections. Conductive thread was the least used and most time-consuming connector. Tape was the most preferred connector as it did not require stabilization support or applying pressure, like in banana plugs or crocodile clips. Banana plugs were the most recognizable connector given the holes provided in boards. When using crocodile clips, many participants made errors such as passing clips through the holes and applying pressure at the wrong points. Although we saw a lot of interest in taping, some participants requested us to cut the tape using scissors, and sometimes they pasted tape overlapping the terminals or inside of boards, leading to malfunctioning circuits. Although our participants could not identify these issues, after we collaborate with them in fixing some of these issues, few participants started to suggest some areas to check when an issue arises or try to reduce the occurrence of the same error. Overall, although we identified a lot of successes in our toolkit design, we also identified several areas to improve. One of the directions that require attention is reducing errors through design. An example is replacing slide switches in power boards with toggle switches in reducing single point failures. We observed that supportive accessory of stand immensely helped to improve the participant agency when making connections. Similarly, to support challenges in using scissors, a custom-made tape dispenser with a press-to-cut button can be introduced to the toolkit. Other directions to improve on include foregrounding and backgrounding visual cues depending on participant context not to confuse the user, and design for small wins that can encourage the user to make personally meaningful digital artifacts. We will focus on these directions in the future research. As final remarks, we have made the fabrication files of TronicBoards open source, so we invite you to use it for research purposes or accessible electronics making. Thank you for listening, and please refer to our paper for more details and feel free to contact us with any questions.